In this lesson, we're going to talk about an introduction to trigonometry. So what exactly is trigonometry? Well, trig refers to triangle. Metry refers to like the measurements in a triangle, the sides of the triangle, the angles in a triangle. And what we're going to go through is we're going to go through the trigonometric ratios, the sine, cosine, and tangent, and what those mean. We're going to talk about an acronym, SOHCAHTOA, which helps us to find the sine, cosine, and tangent a little bit more easily. We're going to solve for missing sides in the triangles as well as missing angles. We're going to do what's called solving the right triangle, and we're going to also mention about angle of elevation and angle of depression. So we'll go through some problems. I'll have some examples you can practice on your own. But the first thing to ask ourselves is, what exactly is the sine, the cosine, and the tangent? Now you can see they're written here in their full form, but we oftentimes abbreviate them with the first three letters. So we say SIN for sine, COS for cosine, and TAN for tangent. And if you see this little Greek symbol here, theta, that just refers to the angle. So when we talk about the sine of an angle, what we're talking about is the ratio of two sides in a right triangle. So if we say, what's the sine of an angle? It's the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and the tangent is the ratio of the opposite side over the adjacent side. Now, an acronym that can help us to remember this is this SOHCAHTOA acronym. And the way I like to think of it is S is for sine, C is for cosine, and T is for tangent. And it's always the second letter divided by the third. So what I mean by that is the sine is the opposite side divided by the hypotenuse. The cosine is the adjacent side divided by the hypotenuse, and the tangent is the opposite side divided by the adjacent side. So if you can just write that down and remember SOHCAHTOA, you're halfway there. So let's look at an introductory example. Say we have this right triangle right here. 5, 12, and 13 represent the side lengths. And we want to figure out, what's the sine of angle A? Now what I like to do is, in my mind, just kind of picture like I'm standing at this angle right here, at this vertex. And what you want to think of is the sine is the opposite side over the hypotenuse. So opposite means the side that's across from the angle. So that's going to be 5 over the hypotenuse, which the hypotenuse is always the side across from the right angle. So that's going to be 5 over 13, and that's your sine ratio. Now we're going to talk about how to use those ratios to solve for things in the coming problems, okay, but let's go through this introduction first. So the cosine now, we're going to say cosine is the adjacent side over the hypotenuse. Now if you're working with angle A, adjacent side would be the side next to that angle. Now you might be saying, Mario, isn't this 13 right here? Isn't this side also next to this angle? And that's true, but the one across from the right angle, we always call that the hypotenuse. So the adjacent side would be the other side that's next to the angle, but not the hypotenuse. So again, cosine is adjacent, meaning next to the angle, divided by the hypotenuse. That's the one across from the right angle. So this is going to be 12 over 13. That's our cosine ratio for angle A. Now tangent is this TOA, which is the opposite side over the adjacent side. So if we're here at angle A, remember opposite is across, adjacent is next to, so it's going to be the opposite 5 over the adjacent 12, and you've got it. Now let's switch our perspectives now. Let's pretend like we're over here at angle B. Okay, let's erase our first guy there. And let's say we want to find the sine of angle B. So if we're here at this angle, the sine, remember, it's the opposite divided by the hypotenuse. Now here the opposite, we're going to have to go across. So opposite is going to be 12 over the hypotenuse, which is always the one across from the right angle, which is 13. So our sine of angle B is 12 over 13. Now what about the cosine of angle B? Well, the cosine, that's the adjacent over the hypotenuse. So here the adjacent is going to be the one next to the angle, 5, over the hypotenuse, which is 13. Now again, don't get confused when you think of next to. See, 13 and 5 are both next to that angle, right? But we want the one that's not the hypotenuse, okay? And then the last one, the tangent of angle B, that's going to be opposite over adjacent. So that's going to be 12 over 5. And you got it. Let's take a look at another example. Okay, for this example number 2, see if you can practice this one on your own. Go ahead and pause the video, draw a diagram here, use your SOHCAHTOA acronym, and find the sine of angle D, cosine of angle D, tangent of angle D. Then switch to angle E and find the sine, cosine, and tangent of angle E. Now, if I was going to do it, what I would do is I'd start with sine of angle D, which is this angle right here, and I would position myself at that angle. So I'd say to myself, okay, I'm right here at angle D, and I want the sine, which is the ratio of the opposite side over the hypotenuse. Now, when I think of opposite, I think of the side across, that's going to be 8, divided by the hypotenuse, which is always the one that's across from the right angle. That's going to be the 17. Now, if we want to do the cosine of angle D, again, we're over here at this vertex, angle D. Cosine is the ratio of the adjacent side over the hypotenuse. Adjacent means next to, that's 15, and the hypotenuse is the one across from the right angle, that's 17. And if we want to find the tangent of angle D, we're going to use the TOA acronym, and that's the opposite side over the adjacent side. So from angle D, opposite would be 8, adjacent would be 15, and you've got it. Now let's switch over to angle E. So what we're going to do is we're going to position ourselves at this vertex, okay, and we're going to say, what's the sine of angle E? It's the ratio of the opposite side over the hypotenuse. So from angle E, opposite would be across like this. That would be 15 over the hypotenuse, which is always the one across from the right angle, 17. The cosine of angle E, we're going to use ca, which is the adjacent over the hypotenuse. So adjacent means next to over the hypotenuse, which is the one across from the right angle. So that's going to be 8 over 17. Now remember, adjacent, 17 and 8 are both adjacent or next to angle E, but we want the one that's not the hypotenuse, not the one that's across from the right angle. So adjacent would be 8, hypotenuse would be 17. And then lastly, the tangent of angle E, this is the ratio of the opposite over the adjacent. So opposite would be 15, adjacent would be the one next to, which is 8, and you got it. Okay, for these next few problems, we're going to talk about how to solve for the missing side. So this is where you get into some application and how do you actually utilize the sine, cosine, and tangent to help you to solve for a missing side. So what you want to do here is you want to position yourself at the angle. So you'd say, okay, they're giving me this 40-degree angle in a right triangle, so I'm going to position myself. You don't have to draw the stick figure, but you just pretend like you're at this vertex, and then you say to yourself, what sides am I working with? Well, I've got the opposite side, which I'm trying to solve for, and the hypotenuse. Now you only want one variable, one unknown. So when I think of the opposite and the hypotenuse tells us about the sine ratio. So we're going to say the sine of 40 degrees equals, remember it's always the second over the third, it's the opposite side, which is x, over the hypotenuse, which is the one across the right angle, 10. Now, if you try to do the tangent, like opposite and adjacent, you'd have two variables, so you wouldn't be able to solve for this unknown. So you just want one variable, one unknown, so that you can solve for it. Now, we want to get x by itself. What's the opposite of dividing by 10? Well, that would be to multiply both sides of this equation by 10. Don't multiply the 40 by 10 and make that 400. Just put the 10 in front of the sign. And now you can see we have 10 times the sine of 40. Now, you're going to need a scientific calculator, or in this case I'm just using a graphing calculator, but we're going to type this in, 10 sine of 40. The other thing you want to make sure of is make sure that you're in degrees and not radians. So you might have to go to your mode, check that you're in degrees. So 10 times the sine of 40 degrees, I'm just going to round to the nearest tenth. That comes out to 6.4. So I'll just say approximately 6.4 is the length of that side. Okay, let's look at number 4 now. So for number 4, this angle is what we're dealing with here. So let's position ourselves at the 65-degree angle. And we want to ask ourselves, what ratio, sine, cosine, or tangent, ties together the opposite side and the adjacent side? Well, opposite and adjacent, that's our tangent, that's our TOA. So we're going to say the tangent of 65 degrees, so it's always sine, cosine, or tangent of the angle, equals the ratio of the second divided by the third, in this case the opposite 7 over the adjacent, which is y. Now we want to get that variable by itself, right? So what I'm going to do here is to get rid of this fraction, instead of dividing by y, I'm going to multiply both sides by y. That way these cancel one another out, but we're trying to get y by itself. So instead of multiplying by tangent of 65, let's divide both sides by the tangent of 65. That way those cancel. We have y by itself. We're going to divide this side by tangent of 65 as well. Keep it balanced. So what we have is y equals 7 divided by tangent of 65. So I'm going to go to the calculator, 7 divided by tangent of 65. I'm going to round to the nearest tenth. You should be getting y equals 3.3, and that's this missing side. Now, let's look at number 5. Same idea. We're going to position ourselves at this angle, 38. You can draw the little stick figure if you want. And you think, okay, what side is this? That's adjacent, see next to. And what side is this? That's across from the right angle. That's the hypotenuse. Adjacent and hypotenuse is our cosine ratio. So we're going to say the cosine of our angle, cosine of 38 degrees, equals the ratio of the adjacent divided by the hypotenuse. So adjacent we said was x, hypotenuse we said was across from the right angle 8. To get x by itself, instead of dividing by 8, let's do the opposite. Let's multiply both sides by 8. So x is equal to 8 times the cosine of 38. We'll go to the calculator, and I'm getting about 6.3. So 6.3 is equal to x. That's that missing side. Okay, for numbers 6, 7, and 8, see if you can pause the video and attempt these problems on your own. We'll go through them together, but it's good to practice just to make sure you really have a feel for it before we move on to solving for the missing angle. So here we're solving for the missing side. What would you do for numbers 6, 7, and 8? Well, if I was going to do number 6, what I would do is I would position myself at the angle here that they're giving us, 17 degrees, and I'd look at, I've got the opposite side and I have the adjacent side. So remember, opposite and adjacent tells us that it's the tangent ratio. So we're going to say tangent of the angle, 17 degrees, equals the opposite divided by the adjacent. So that's going to be 9 over x. Now, another way to do this problem and solve for x is to think of this as being over 1, because anything divided by 1 is itself. And a shortcut, if you like shortcuts, and this is a property of proportions, is you can actually interchange these on the diagonal. So you could put x over here and tangent of 17 over here. That's a quick way to get x by itself, because x divided by 1 is just x. But some students are not so comfortable with that, so what you might want to do is just cross multiply. You probably learned this when you learned about proportions, the cross product. So you'd say x times the tangent of 17 equals 9 times 1, which is 9. We want to get x by itself, so instead of multiplying by tangent of 17, let's divide both sides by the tangent of 17. And these cancel, so let's see. Let's go to the calculator. 9 divided by the tangent of 17 comes out to, and I'm just rounding a little bit here to the nearest tenth, so let's say 29.4. So this is 29.4. Okay, number 7, let's try this one now. So what did you do on this problem? Well, again, I like to kind of draw my little stick figure person here, and then I think to myself, okay, this is the angle, and I've got the adjacent side, which is next to, and the one across in the right angle, which is the hypotenuse. So when I'm thinking adjacent and hypotenuse, we're thinking of the cosine ratio. So that's going to be the cosine of 22 degrees equals second letter over third, adjacent over hypotenuse. And now what we're going to do is we can do that little trick where we can cross multiply or switch these on the diagonal. So whichever one you're most comfortable with, or if you don't like either of those, you can do what we did earlier, which is to multiply both sides by x. Those cancel. Now we have x times the cosine of 22 degrees equals 13, but we want to get x by itself, so instead of multiplying by cosine of 22, we're going to do divide by cosine of both sides by 22 degrees. And now you can see 13 divided by cosine of 22 gives us x, and that is about 14.0 if we round to the nearest tenth. Okay, and then for number 8, what did you do for this one? Well, again, if I was going to do it, I put my little stick figure, I just kind of pretend like I'm standing here at this vertex, and I say, okay, I've got this angle, the opposite side, and the one across from the right angle, which is the hypotenuse. Opposite and hypotenuse is the sine. So we're going to say the sine of the angle, 50 degrees, equals the opposite, which is x, over the hypotenuse, which is 17. And then instead of dividing by 17, what we'll do is we'll multiply both sides by 17 so that we get x by itself. So what is 17 times the sine of 50? Let's do that on the calculator. Okay, and that's coming out to about 13.0. And one other thing I just want to point out real quick, because sometimes if you're having a little bit of trouble with this still, what you might want to do, and some students like to do this, is as soon as you set up your triangle and you position yourself, you might actually want to write, okay, across opposite, maybe put an O, and then you say, okay, across from the right angle, that's the hypotenuse H. So then really all I'm left with is A, right? That's the only other, we only have opposite, adjacent, and hypotenuse, but we know adjacent is next to. Then when you look at it, you say, okay, opposite and hypotenuse, I can see I'll only have one unknown here. So yeah, opposite and hypotenuse, that's going to give me my sine ratio, and then you can proceed from there instead of having to remember it in your mind. Okay, for number 9, 10, and 11, what we're going to do is we're going to solve for the missing angle now. So a little bit different from the last few problems. What you want to do is you're still going to be working with your sine, cosine, and tangent ratios, but we're going to be doing the inverse sine, inverse cosine, and inverse tangent. So what you're going to do is you're going to position yourself at the angle like we've been doing, and you're going to be saying to yourself, okay, this angle, we've got the side opposite and we have the side adjacent. And remember, opposite and adjacent, that's our tangent. But what we're going to do now is we're going to say the tangent of x degrees equals the opposite divided by the adjacent. So opposite's across, adjacent is next to. We want to get x by itself, so what you can do is you can take the tangent inverse, which is represented by this little -1 here, of both sides of the equation, so tangent inverse, and what happens is these undo one another, so it gives us our angle by itself. So x degrees is equal to the tangent inverse of opposite over adjacent. Now, you can skip that first step if you want as you do this more and more. Just realize that if you're solving for the angle, you're going to use the inverse sine or inverse cosine or inverse tangent. Now, on your calculator, you might need to press the second key, okay, and it should be right above your sine, cosine, and tangent keys. So it should be second tan, so that's tan inverse of 10 divided by 12. Each calculator is a little bit different. You might have to play around with yours a little bit and kind of find out where that's located. If you're doing it on a smartphone, it's a little bit different as well. So just play around a little bit with that, but this is how you would solve. So this would be 39.8 degrees. Now we're solving for the angle, right? So for number 10, let's look at this one. We're going to position ourselves at the angle, and it looks like we're given the opposite side and the hypotenuse, because it's across from the right angle. Again, remember you can label it as O, A, and H, okay? So we want to find this angle, and we're given opposite and hypotenuse, that's sine, but since we're solving for the angle, we're going to do the sine inverse of the opposite over the hypotenuse. Again, we're going to go to the calculator, I'm going to press the second key, sine inverse of 2 divided by 9, and I'm getting about 12.8 degrees. Okay, that's this angle right here. And then number 11, again, we're going to position ourselves at the angle, and it looks like we have the adjacent side and the hypotenuse. And you can see adjacent and hypotenuse, that's our cosine. But because we're solving for the angle, we're going to use our inverse cosine, or our cosine inverse of adjacent over hypotenuse. Now remember, the ratios are still the same. Just because you're doing the inverse, you're still going to do second over third, second letter over third. And cosine inverse of 5 divided by 11, cosine inverse of 5/11, which comes out to 63.0 degrees if you round to the nearest tenth. So that's that angle right there. Okay, number 12, 13, and 14, see if you can do these problems on your own. Pause the video, draw these diagrams, write down your SOHCAHTOA acronym, and see if you can solve for these missing angles. Now, while you do that, I just want to mention that if you like my teaching style, I have an Algebra 2 video course for sale that goes more into trigonometry and goes into college algebra topics. So if that's something you're interested in, I'll put a link in the description below. Check that out. But let's dive into these examples now. If I was going to solve this, I would position my stick figure here at the angle, and I would say to myself, what am I working with? I'm working with my opposite side and my hypotenuse. So that tells me that this is my sine ratio, and because I'm solving for the missing angle, I'm going to use the sine inverse of the opposite divided by the hypotenuse, which is going to be the 4/18. Now, if we go to the calculator, this is coming out to 12.8 degrees. Okay, for number 13, what did you get for this one? Well, again, I would position myself at the angle, and I'm looking at the ratio of the opposite side and the adjacent side. So that's telling me that it's the tangent, and because we're solving for the missing angle, we're going to use the tangent inverse. So that's opposite over adjacent for tangent. So if we do that on the calculator, that is coming out to 39.8 degrees. And we're going to go into number 14, and we've got some more problems after this as well. We're going to talk about solving right triangles and also a little bit about angle of elevation and angle of depression, so stick around for that. If I was doing this one, I would position myself at the angle. It looks like we have adjacent and hypotenuse, so x is going to equal the cosine inverse, the adjacent and hypotenuse, of the adjacent over the hypotenuse, 1/4. So that's going to be cosine inverse of 1/4. And I'm getting an angle of 75.5 degrees approximately. And you've got that one. Okay, for number 15 and 16, we're going to talk about solving the right triangle. And what that means is you're solving the entire triangle. You're finding all the angles and all the sides. So I'll do number 15 and kind of show you how this works. You can try number 16 on your own. We'll also go through that one together. So let's dive into number 15. Now the question is what should we solve for first? Well, it looks like they're giving us two sides of this right triangle. So we can solve for this third side. I think I'm going to do that first, and I'm going to use the Pythagorean theorem. We haven't done that yet in this video, but remember, in a right triangle, you probably remember this from Algebra 1, a squared plus b squared equals c squared. So it means the sum of the two legs squared, the sides that make up the right angle, okay, those squared add up to the hypotenuse squared, which is the one across from the right angle. So if we do this, we can see that we're going to get 7 squared plus z squared is equal to our hypotenuse squared, which is 25 squared. So if we do that, we get 49 plus z squared equals 625. If we subtract 49 from both sides, we get 576. And if we take the square root of both sides, we get 24. So you can see now we've got all three sides. We want to solve for the angles now. So say if I wanted to solve for this angle x. Now what I like to do, and you might want to do this too, is I tend to go back to the original numbers that they gave me because they're exact, they're not maybe rounded. In this case, 24 came out nice and even, but say if I made a mistake on a quiz or test and I used this number and it was wrong, then I carry that mistake forward. So if you can, try to go back to the original numbers. That'll help out a lot. So now if I want to find this angle x here, I can see that I've got the opposite and the hypotenuse. So that's the sine, but because we're solving for angle x, we're going to do the sine inverse. So x is equal to the sine inverse of opposite over hypotenuse. So 7/25. So let's do that on the calculator. Sine inverse of 7/25. That's coming out to about 16.3. So I'm just going to label this here 16.3 degrees. And these two angles, the two acute angles in a right triangle, they always add up to 90 degrees because 90 plus 90 is 180. So a quick way to do this is just take 90 minus 16.3, and that gives you the other angle, which is 73.7 degrees. And now you solve the triangle. You found all three angles, all three sides, it's solved. So see if you can pause the video and do number 16 on your own. It looks like we're solving for this side A, this side C, and this angle Y. So go ahead and try that one. And while you do that, if you like the way that I'm explaining things, and you're like this Mario guy of Mario's Math Tutoring, like I get how he explains this stuff, you know, it's because I tutor students every day, you know, full-time, working with students in my local district. And so I try to incorporate things that I see students struggle with into these videos to kind of show you how to avoid some of the same mistakes and make things a little bit easier. So if you like that, you know, go ahead and follow me on this channel. But Let's dive into number 16 here. So this one, what we're going to do is we're going to find out this side right here. And the way I'm going to do that is I'm just going to use this angle, this side, and this side. So that's the opposite and adjacent, which speaks to the tangent ratio, right? So we're going to say the tangent of 25 degrees is equal to 8 over a. Now, I'm going to multiply both sides by a to get rid of the fraction there, and then I'm going to divide both sides by tangent of 25 to get this a by itself. So it looks like a is going to equal 8 divided by the tangent of 25 degrees. Let's see what that comes out to. 8 divided by tangent of 25, and that's about 17.2. So let's put that right here. And now angle y, this one's pretty easy because we already have these two angles. We could add them up and subtract from 180, or the two acute angles add up to 90, so 90 minus 25 is going to be 65 degrees. And now I could do the Pythagorean theorem, a squared plus b squared equals c squared, and find that hypotenuse, but this is a rounded number. So I'm going to go back to the original numbers, which are the 25 and the 8. So it looks like I have the opposite and the hypotenuse, which is the sine. So what we're going to do is we're going to do the sine of 25 degrees equals the opposite over the hypotenuse, which we called psi c. So now what you can do is you can cross multiply, or on this last problem, since I'm running out of space here, I'm just going to use the little shortcut method I mentioned earlier where you can switch these on the diagonal. So I'm going to put c here, c over 1 is c, is equal to 8 divided by the sine of 25. So let's see what that comes out to. Okay, and I am getting about 18.9. So that's that third side. So now you solved the triangle, you found all the angles, all the sides. Let's take a look at some story problems, some angle of elevation, angle of depression problems next. Okay, now what we want to do is we want to bring this trigonometry into the real world. We want to say, how do we actually use trigonometry to help us in real life, right? So that's where the angle of elevation and angle of depression can come in. And what I want to point out is angle of elevation is basically like you're standing here and you're elevating or you're looking up, okay, to that line of sight. So in this example here, you can kind of like think of that angle of elevation as up from the horizontal. Now, angle of depression, you're looking down, okay, from the horizontal, like this. So that would be this angle right here. So whenever you're doing an angle of elevation or an angle of depression problem, you can always draw like this rectangle like I'm drawing here. And the angle of elevation, angle of depression, those are actually going to be congruent. They're alternate interior angles because these lines are parallel. And you probably remember that from geometry, right? So now what you want to do is you want to realize that this length and this length are the same, this side and this side are the same, and so you can use that to your advantage to realize that there's two triangles here. Sometimes students get a little bit confused when they see a triangle. They think of this as the angle of depression, but you always want to go down from the horizontal, elevation up from the horizontal. So let's take a look at number 17 and 18. I'll do 17, maybe you can see if you can do number 18 on your own. Say, for example, you want to find the height of a tree, like a pine tree. What you could do is you could walk back from that pine tree like 100 feet. Look at your angle of elevation. You might take a protractor or estimate, approximately what that angle of elevation is to the top of the tree. Then what you can do is you can say, all right, I'm going to find this height of this tree. It's a lot safer than actually climbing the tree with a tape measure, right? So you're on the ground. So you say, well, what trig function ties together this angle, this side, and this side? Well, it looks like we have opposite and adjacent. That's our TOA, which means that this is going to be the tangent of 58 degrees is equal to the opposite side over the adjacent side. So if we multiply both sides by 100, that's going to give us the height by itself. So let's do that on the calculator. 100 times the tangent of 58 comes out to about 160. Okay, so that means this tree is about 160 feet tall. Okay, now for number 18, see if you can do this one. Imagine if you're flying a kite, okay, and you let out 300 feet of string, and you approximate that angle of elevation to be 65 degrees. How high is the kite above the ground? Now, the one thing that we're missing here on this problem, and this adds another layer of complexity, is imagine if you're holding the string like at maybe waist level or so. See, this might be 3 feet above the ground, right, where you're holding the string. So when you get this height, you'll have to add 3 to it to get, the actual height above the ground. But in this case, we're mainly working with the triangle, but just an added step, we'll add an additional 3 feet to get the direct height of the kite above the ground. So what would you do for that one? Go ahead and pause the video. If I was going to do it, I would see that I have the opposite side and the hypotenuse. So that tells me opposite and hypotenuse, that's the sine. So that's going to be the sine of 65 degrees is equal to the opposite over the hypotenuse. And then instead of dividing by 300, we're going to multiply both sides by 300. And so let's see what that comes out to on the calculator. 300 sine of 65. It looks like it's 271.9. If we want to add the 3 feet on here, that's going to be about 274.9, or about 275 feet above the ground. So great job. If you want to see more examples, you want more practice, you want to see me explain more about trigonometry, I'll put a video right there talking about introduction to trigonometry, like a basic trigonometry basics. So follow me to that video there. We'll do some more practice, and I'll see you in that video.